This is a video I wanted to make some weeks back, but fortunately or unfortunately, I don't know, another guy who I don't know came out with a similar video. Not the same, but similar, somewhat similar. And he included things I wouldn't have included. Anyway, either way, I didn't bring up my video at the time because it would be either overshadowed or in competition with the other person's video because they were similar topics. But this is the video I was going to bring out before this other man brought his video out. A doctor somebody is his name. Is he an engineer or something? I can't remember, but he's a flat earther anyway. But anyway, long story short, I'm going to go through something here now that certain things can happen if the Earth's a globe. Right? There's certain things in reality that we don't have the use of, etc., 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 that we couldn't do, that wouldn't exist if the Earth was a globe. Right? Now, of course, the first thing that doesn't exist if the Earth's a globe is angular size change, because there is no, if I just look at Metabunk here, there is no angular size change, there is no perspective effects. Like even here, when they go to pure angular size results, it's angle between eye level and the horizon. So that's a pre-assumption that the horizon is the geometric edge. Here it is down here with an X. Geometric edge of a globe Earth. And that it's a point of tangency. Do you know what I mean? So they're pre-assuming that it's a geometric point of tangency. So the angle between eye level and the horizon, right, is a pre-assumption of the horizon being a geometric edge of a sphere Earth of radius 3959 miles, and it being a geometric point of tangency, right? Angle between eye level and the bottom of the target, that's still a nothing. That's just still a dip angle from the eye line. From there is the eye level here, straight line. Right, don't forget that the eye level is always straight line. Here it is. So it's a dip angle from the eye level. That's all it is. So both of them are not, like, you don't need perspective for those two. But the other side of that is you need an angle, which is a perspective size, right? So that's kind of defeatist, right? It defeats the globe, just those two there. The third part here is the angular size of hidden amount, right? So the amount of the object that's hidden, they're giving you the angular size of that, right? But that's a nothing, right? Because they're not addressing the angular size of the object to begin with, and they're not addressing the angular size of the object that would, its angular size of the part that you would be able to see if they hadn't, let's just say, if they hadn't hijacked perspective and made it into our curve. If they hadn't done that, if the Earth was a globe and perspective existed, then, you know, it would be included in our maths, but it's not. There's no, this is the geometric results, right? They're the results that matter. There's no perspective involved in there. There's no angles in there. There's no visual occultation, optical drop, angular size change with distance, angular resolution limits. None of these things are involved there. It's all about how much geometric blockage is in your way of seeing whatever object, right? Or how much of whatever object is blocked by this geometric hill of Earth curve, right? So there's no perspective involved whatsoever, or accounted for in any way, shape, or form within the heliocentric paradigm. There is not. It just doesn't. But terrestrially, celestially, they do have to take perspective into account, because they have to say that the sun's size is its angular size, and the moon's size is its angular size, and they work out all, they do back engineering sizes based off of these things. Point is that when it comes to terrestrial observations, it's just Earth curve, everything Earth curve. You know what I mean? There's no anything else. There's no, they don't even they won't even address even things like inferior mirage. Do you know what I mean? Even things like that. No, it's Earth curve. Do you know what I mean? For a long time, people were being told that a ship was disappearing behind and over an horizon. And most of the time it was just an inferior mirage that people couldn't see because it was at too much of a distance. It wasn't until people got super zoom cameras back in the 2014-15 time that people could see, no, it's not, it's just inferior mirage. Do you know what I mean? Not our curve, none of that nonsense, just a mirage. You know, what you're seeing here is a mirage. Do you know what I mean? It's but not in the way they want it to be. So it's a joke. You know what I mean? The whole heliocentric globe model is complete farce. And I'm just going to show here how much of a farce it is, because this is something that does exist in reality, that we do and use, and we do know about and use in reality all the time, constantly used, and can be used at any time you want with small and big objects. It doesn't matter. And it works exactly the same and always works, doesn't fail. Distance doesn't stop it failing as long as you can see the object. Nothing, you know, as long as you have the details you need, it never fails, right? Which is, right, angular size change with distance, right? So here we have the height of Kathmandu Valley, right? It's an elevation of 4,344 feet. Right, 1,324 meters. Now I've seen a couple of different variations of the height, but it's all around that, right? But we're going to go with 4,344. It doesn't matter, right? And you have Mount Everest, right? It's 29,030 feet high. So you have two vertical, right, elevations, which could only come from a horizontal plane. Once again, flat Earth, right? But what we have is we have people claiming that they measured the height of Mount Everest, right? There's part of the measurement of Mount Everest and its elevation was people that were close on 100 miles away from Mount Everest, which Kathmandu Valley is, right? So I think it's 90 something miles away, right? 94 or something. I have it down at miles away. Point is, it's between 94 and 100 or something like that. And from Kathmandu Valley and other areas around Mount Everest that are about 100 miles away, about the same distance, they were measuring the angle to Mount Everest, measuring its angular size. Obviously, right, they had to account for their own elevation, right, which is 4,344 feet, and extract that from the 29,030 feet, right, in the process, right. Now, if we go to here, right, it's viewer height in feet. So let's say 43, what was it? Sorry, there now, 4,344 feet, 4,344, right. Distance in miles, I'm going to put down 94 miles, right? So that would mean now, if you look at this within their geometric calculations, right, geometric hidden amount is only 117 feet, right? So you think, no big deal, right? And this is how they sell it to people. It's not a big deal, it's nothing. But this is the problem. When they're measuring the Mount Everest, and if they're claiming to be on a globe, there's issues, and I'm going to show that now. So I've shown these, right? There's the elevations, right? Now, in reality, right? Let's say this is Kathmandu Valley here, right? And this is Mount Everest, right? From Kathmandu Valley, even on a globe, you could see almost at the bottom of Mount Everest. If there was nothing else there in the way, you couldn't because there's other mountains in the way. But if it was just a clear path, even on a globe, now this is obviously a horizontal, but if we're using a globe, from Kathmandu Valley, you will be able to see to almost the very base of Mount Everest, right? Close on. But if we're talking about measurement here, we're not talking about just seeing, we're talking about measurement. So what they had to do was, sorry, I keep on messing around with that. What they had to do was measure, make a 90 degrees, right? So from above there, so I'm just going to go here, I'm just going to get, right? So they had to make a 90 degrees from where they were. Let's just say if they were in Kathmandu Valley or any similar place around around 100 miles away from from Mount Everest, because this is how they first measured it, right? And they would have had to make a 90 degrees from the zenith, right? And then what they'd have to do is subtract the elevation, the known elevation of Kathmandu Valley, right, from the full, what would be the full height, the eventual height of Mount Everest. So they'd have to first say, right, whatever height Mount Everest is, we'd have to subtract the 4,344 feet, the 4,344 feet of elevation of Kathmandu Valley, right? So their calculation is going to be, right, this straight line is going to be parallel, this straight orange line here is going to be parallel with this green line, right? This is the Earth, this is let's say sea level, right? This green line. I make it even, I make it blue, right? So that's sea level, right? This is 4,344 feet above sea level. This is the horizontal, this orange line, the horizontal that they're making, right? This is the angle line to the top of Everest, and this is obviously the vertical that they measure, right there, right? So I make that vertical, make that green, just to make it stand out, right? So the green is the vertical that they measure, right? So they know that they're this much above, right? Because let's just say if this blue line here is all sea level, then this amount here, I'm just going to make a little, it's going to get, right, let's put that in, right, so they know that that amount there, sorry, I think I'm a bit off, yeah, so they know that this amount here is their, right, on Mount Everest, right, down, straight down from the peak, is their height in Kathmandu, Kathmandu Valley, sorry. And they're going to measure the angle above that. So they're measuring this green. So they already know the height of Kathmandu Valley, and they're going to have to subtract. So they're going to measure just this much, right, as opposed to measuring from here up, right? They're going to have to start with a horizontal baseline. But that baseline has to be parallel with sea level, right? For them to do this, that baseline, being 94 miles or 100 miles long, whatever, it has to be parallel with sea level. And that means sea level has to be horizontal for this to work. It can't work any other way. It's the only way it can be done, right? So this is what they would have had to do. So if we just go by, let's just say someone was measuring the height of Mount Everest from 94 miles away, and they were taking an angular size from sea level. If they could see the peak of Mount Everest from somewhere at sea level, then they would have had a 3.3515 degree angle, right? Because Mount Everest is 5.5 miles high, and the distance is, let's say, 94 miles, as I said. But when it comes to Kathmandu Valley, I got it right that time, from 94 miles away, they would have to, their height, the height to be measuring would be 4.6773044 miles, right? They won't be measuring a full 5.5 miles of Mount Everest then, because when you subtract the elevation of Kathmandu Valley. So they would have got a 2.8504 degree angle, right? Now, this means that at the top of Kathmandu Valley, right, this angle here that they would have got, right, this would mean that that if they knew the distance to Mount Everest, and they did, this would allow them to then determine by that angle the actual size of of all of Mount Everest that's above the elevation of Kathmandu Valley, right? So this would mean that this orange line has to be a straight line, and that the blue line underneath, which would mean sea level, has to be a straight line. So they both have to be parallel horizontals. And that when they measure this green line here, when they measure that, I'll make it a little bit thicker. When they measure the green line there, right, that means that they have to know that when they're measuring that the angle they get there is covering all of that extra elevation. So this first part of the elevation is Kathmandu Valley. The second part has to be the rest of the elevation of Mount Everest, right? And by doing that, if they know the basic distance between this point here and this point here, right? Distance is going to be lateral, right? Because miles, kilometers, meters, feet, inches, centimeters, kilometers, you know what I mean? Nautical miles, it's all straight line horizontals as an origin. And if they're measuring a distance, they're going to be measuring it like that. So there's no way for this blue line to be curved and for this to work. It can't work. And I'll show in a minute why not. But they did do this, and they did get the height of Mount Everest. And even years later, back only in recent times, I think it was last year or year beforehand, they came up with a final measurement of the height of Mount Everest. And there was like 8 feet of a difference. So the original measurement that was done in this way, they got them basically the exact height of Mount Everest, let's just say, right? That would mean, though, the only way for that to happen would be for mean sea level to be a horizontal, because there's no way for this to be done unless it is, and I'm going to show why. So here I have, right, so I'm going to go up, sorry now. Here we have 3 circles, right? The red circle is the globe Earth, right? That's the mean sea level of the globe Earth. The orange circle here is Kathmandu Valley. That's the height of Kathmandu Valley above a globe Earth. And the green circle is the height of Mount Everest above a globe Earth. Now, the problem is this. I brought a 90-degree angle from this zenith, right? That would have come from here. Sorry, that would have been here. If they're on a globe Earth, they would have been measuring from here, Kathmandu Valley, and be a 90-degree angle, because a 90-degree angle, and of course, because it's all the zeniths are meeting at a central point. They're not verticals. You can call them a zenith if you want, but they're not a vertical. This means that they all diverge. So even though someone standing there could, if there was nothing in the way, almost see the base of Mount Everest, the point is that when they're trying to do this process, that won't work. So the Earth can't be a globe for this process to work. But it's a process that does work, and we use and have all the time in reality, and can use it at any time. The problem is when you take that 90, right, which they would have had to do for their measurement, right, what happens is that, I'm just going to make it as clear as possible, right. What happens is this, right. So this is the vertical height. Well, sorry, that's not vertical on a globe, but this is the elevation of Kathmandu Valley above the surface of a globe Earth. This here is the line that's making a 90 with the zenith that's above the person in Kathmandu Valley. And this red line here is the amount then they can measure, right? This is the problem. But there's this point here between this point and this point that's unmeasurable. Because you can't, you have to use a 90 degrees to measure an elevation angle. And the baseline has to be horizontal. Well, when I say horizontal, in this instance, in their paradigm, it can't be, right? There's no horizontals or verticals. But the point being, so they just have a straight line. So they're trying to measure an elevation angle, but they can't. Number one, they can't do it because they don't have horizontals and verticals. Number two, there is no angular size of anything, because angular size and perspective doesn't exist in their paradigm. It's not part of their global maths. Number three, they have divergent zeniths, right? Which means that this section here of Mount Everest, between the Kathmandu Valley and the peak of Mount Everest, that whole section can't be measured. So that means that this could never have worked on the globe Earth, because there's no way for it to work. Because no matter what way they twist or turn it, they won't be able to measure from here up to here. They'll only be able to measure from here to here. And they'll be lucky to even know what this height is, considering the situation. Right? Because considering that they think level is a curved line, right? How can a level be a curved line, right? Not only is that means that level is either one-dimensional or three-dimensional, right? When level is two-dimensional, level is no point higher or lower than another, right? So how could you even get an elevation to something if level is just one point on the surface of a globe? You can never determine an elevation, as is proven here. Elevations are impossible because when they're trying to just, like the highest peak that we know of above sea level, right? Or there's some argument with there, but that's fine. But let's just say, we'll say for argument's sake, it's the highest peak, right? Above sea level, Mount Everest, right? Even something as big as that, can't measure it if we're on a globe. Because you don't have angular size change. You don't have parallel zeniths because they're not verticals. You don't have horizontals. And you don't have, you're because you have divergent zeniths, what's happening is that the 90 degrees angle that you are creating, I don't know how you'd even have a 90-degree angle, but the point is that the one that we've created here to show the issue, right? If they were trying to deal with, right, which would be a 90 degrees off of their zenith, right? So from zenith down to 90 would mean that this whole section here would never get measured. So the whole thing would be a disaster. Can't work on a globe. You could not measure an angular size and determine by its angular size, if you know the actual distance between you and the object via the angle, with the angular size, you can determine the height of the object. If you know the actual size of the object, but you don't know your distance to it, measuring the angular size of the object will give you the distance. So to get the distance, you need the actual size. To get the actual size, you need the distance. But right, so that's what you need, and you can't have that on a globe. It just can't. It just doesn't work. Can't be done. It's an impossibility, and this just shows it. Because you can do this process with the lampposts on your street, or you can do it with the local mountain that's 50 or 60 miles away, and it works all the time. It never doesn't fail. It always works. But it can't work if the Earth's a globe. It can only work if you have. It can only work if you have horizontal baseline, right? Right, you have horizontal and vertical. So here we have two parallel verticals, right? As the zeniths, as the two zeniths. Let's just say this is what's being measured here between this point and here. And here you have the person measuring, that's their zenith, which is a vertical, right? And you have this orange line here that is parallel with mean sea level there. And that's why this process works. The reason that they could measure the height of Mount Everest and the reason they could do all these things is because the Earth is flat. If the Earth was not flat, there'd be no way for them to use this way of measurement, this process of measurement to measure the height of anything. It would be impossible. I don't even know how you determine elevations on a globe because you've nothing to reference. Like, what's the reference? The point underneath your foot? That's no reference, is it? It's not a reference. The center of a globe, that means nothing. You can add on that distance as well. So I'm 20 foot above sea level and there's also 3,959 miles below me. Right, that's great. So I've measured up to 20 foot. Now, how do I measure the rest? Do you know what I mean? It's a disaster. How do I know the difference between where I am now and somewhere else? The whole thing is a complete mess. None of it works. The Earth has to be flat for any of this to happen. So the fact that we use this in real life all the time, and it can be used, you can do it on your kitchen table with some small objects, or you can do it with a mountain 60 miles away, 100 miles away, it doesn't matter. And it'll always work. It'll always give you an answer. And you won't end up with a whole part of what you're trying to measure missing from your measurement. That won't happen because the Earth is flat. Thanks for watching.